Those 7 properties of parallelogram we are going to use. Wherever it is required, there we have to use. Also, I hope we have seen all the types of quadrilaterals. When it will become what shape? Parallelogram, for example, parallelogram to be a rectangle. What condition it should satisfy? One angle should be 90 degree. Okay, got it. Now this exercise 8.1. Have you gone through what are all the questions are tough for you, or shall we see everything? Also, I am not going to write the exact proof. Exact proof, no, as per your exam point of view, what we are writing, no, that I am not going to write. Only the key points I will write. Based on that, we will move forward to the next question. Is that okay, or shall we write full detail? Say yes or no. I am waiting for your response. That is okay. Okay, all the questions we can do in that manner. Got it. If the diagonals of a parallelogram are equal, then show that it is a rectangle. This question number 1. Diagonals of parallelogram equal, then it is a rectangle. How do we prove? For that we need a parallelogram. Let us name it ABCD. Okay, we need to prove any one angle is right angle. Okay, so the diagonals are BD and AC. Okay, so we need to prove a given particle. You have to write angle A is 90 degree. Okay, how we can prove? If we can able to prove that angle A, what we know about A is nothing. That A is equal to C. Already it is equal. We can't say anything about it. Okay, and A is equal to B. A plus B is 180 degree. Suppose if we can able to prove both A and B are equal, easy to prove angle A is 90 degree. So we need to identify the triangles in which has the angles A and B. So this is one triangle and this is another triangle. Can you differentiate these triangles? So in triangle ABC and triangle ABD, not ABD, this BAD I think, because we need to prove AC is equals BD. AC is equals BD should come, so BAD we should write, not ABD. So in that AB is common, obviously. Okay, and what else we can say? Come on, look the diagram. AD is equals BC. Okay, that is wrong. BC is equals AD. That is opposite sides of, no sir, sides of ABC only should be written here. If you write AD here means that is wrong. And then the angle which is common between these two, like shall we say these two angles are equal? No. What else are equal? Can you say? AB is common. Okay, this is okay. And then anything else? What else you may say, Dan? Come on, look at the diagram. This A is equals to B. That is what we need to prove. No man, it is not. If the diagonals of a parallelogram are equal, I left that part. Sorry. See, diagonals of a parallelogram are equal. That is what the question is. Okay. So diagonals equal. That is AC is equals BD. Okay. It is given. I left this part. I was searching for an angle. So in a hurry. Then what we can say by what congruency? SSS congruency. We have this triangle ABC is congruent to triangle BAD. Okay, so that gives angle A is equals angle B by CPCT. Also we have this angle A plus angle B is equals 180. Why? Adjacent angles of parallelogram. Okay. Why means these two lines are parallel, right? And this axis AB axis is a transversal. So this is angles in the same side of the transversal. So when you substitute this, so 2 times angle A is equals 180. We have angle A is equals 90. So ABCD is a parallelogram given, diagonal already equal. So one angle became 90 degree. Then what we can say? So therefore ABCD is a rectangle. Got it? Likewise, the second question. Show that diagonals of a square are equal and bisect each other at right angles. There are 3 sections of the proof. We need to show that the diagonals of square are equal and bisect each other at right angles, right? So 3 sections. For that, first we need a square. Let ABCD be the square. First thing we need to prove the diagonals are equal. How we can prove the diagonals are equal? This AC and BD are diagonals. We need to choose 2 triangles in which this AC and BD are sides of the triangle. So I am choosing this triangle ABD and this triangle ABC. Okay. Or else we will use 2 different colors. Can you differentiate these 2 triangles? In triangle ABD and triangle ABC, what are all the common things we have? Diagonals are equal, we should not say, because in previous question, the question itself they gave, but here we should not say, we need to prove that one. Okay, so we have angle A is equals angle B. Okay, again see BD, AC it is coming, not coming, so BAC will write. So each 90 degree. Shall I erase that? Shall I erase? Anything common between these 2 triangles that you notice in the diagram? AB is equals BA, that is common. Yes, sir. Of course. And then, where was I? This side, AD is equals BC. Shall I write AD is equals BC? Yes. That is sides of square. What congruency, man? SSS or something else? 90 degree involved. Must be RHS, right? What congruency? Unmute yourself and see. by SAS congruency, this triangle ABD is congruent to triangle ABC. For what we, sorry, not ABC, BAC, then only that makes sense. So then by CPCT, we have AC is equals BD. Okay. So therefore diagonals are equal. One part of the proof over. See, diagonals are equal, one part over, and they bisect each other. Bisect each other means these parts are equal, we need to prove. How do we prove? We need to look for a triangle in which these mentioned marked sides are the sides of a triangle. So let the intersection point of intersection, the second one, to prove diagonals bisect each other. Okay. So O be the point of intersection. PO in a not P man, this point of intersection. So look for the triangle that has these parts as their sides. So triangle AOD and in triangle BOC, hey, no, I don't think we need to struggle this much. Okay, we'll see. These opposite angles are equal. And then we have this angle is equal to this angle, alternate interior angles, remember. Also these two sides are equal, then what congruency will apply? This angle AOD equals angle BOC, they are vertically opposite angles, and then this angle CBO is equals, not CBO, here only CBO equals here CBO, then here what is this angle? ADO only, right? Yes, ADO, not ADO, ODA. Correct now. ADO. Then these two are what angles? Alternate interior angles. Also we have AD is equal to BC. Those are sides of a triangle, sides of a square. Then what congruency shall we apply? Two angle, one side. Is that ASA or AAS? These two angles not having a common side. So it is AAS. It is not ASA, man. The side is not in between these two angles. The AAS congruency. Or one another way is there. We know that this square is a parallelogram, right? Question itself they gave it is a square, right? So it is a parallelogram. AB is parallel to CD, we know. Also BD is AD is parallel to BC, we know. Okay. We already know that in a parallelogram, diagonals bisect each other. Remember? Remember property among the 7 properties. So the diagonals bisect each other. So we can prove like this. I don't know your teacher how they are evaluating. If you can write that manner also, they will give marks, means you can write in that way. How they given the proof in your school? Same manner or different manner? Okay, that is it. Then they bisect each other. Yes, sir. alternate interior angle. Yes. Can I write this side? We'll draw a new diagram. Okay. By AAS congruency, we may say this triangle AOD is congruent to triangle BOC. Okay. That is it. They bisect each other. We proved. Next, the third one. To prove they bisect each other at right angle. This angle ADO is equals 90 degree. So we already know these parts are equal. Okay. Since those diagonals are equal, their halves are also equal. So for that we need to prove this angle. I am choosing this ADO. Sorry, not ADO. AOD. I am choosing this AOD is to be 90 degree. To prove this, we need to choose any one of this linear pair, so that if we can able to prove those two are equal, means sum of those two 180, and then if they are equal, each 90. That is what it gets. So I am choosing this pair. So this angle AOD is a part of a triangle AOD, and this triangle DOC. Those two angles are equal. I am going to prove. How we can prove? It is easy. We already know that this AO is equals, oh sorry man, it's not DOC, COD. AO is equals CO, because diagonals bisect each other. So from second one, and after that AD is equals CD, that is sides of square, and then anything else? Yes. OD is common, man. OD is equals OD. So that is common. So we can prove by triple S congruency, this triangle AOD is congruent to triangle COD. So that gives us then angle AOD equals angle COD, but they are linear pair. This angle AOD plus angle COD, that is equals 180 degree. When you substitute this equal relation here, we get 2 times angle AOD equals 180 degree. That gives angle AOD is 90 degree. From the first subdivision, we proved that the diagonals are equal. Second one, they bisect each other. Third one, they bisected angle is 90 degree perpendicular. Okay, that is it. The second part also you can reduce by writing, by taking square as a parallelogram. Diagonals bisect each other. That property you may recall. Okay, any doubts on this, man? Shall I erase this half? Write fast, write fast. Okay. Okay. So I erase this half. Okay, man. Third question. Look at the third question. Diagonal AC of a parallelogram ABCD bisects angle A. So that is ABCD. Diagonal AC of a parallelogram bisects angle A, which means these two halves are equal. And then we need to show that it bisects C also. How we can prove this? Simple, by congruency. If we can able to prove these two halves of C also equal, which means AC bisects C. Two possibilities are there. By triple S congruency, this side is equal to the other side, these two triangles. This side is equal to other side, one side common. Triple S congruency, that gives us these two angles equal. Okay. Or else we can take these two lines are parallel. This angle is equal to this angle. This angle is equal to this angle. And we may say what? By ASA congruency. Which one would be easy? Which one would be easy, man? AC bisect C. So in triangle ACD and triangle ACB, we have AC is equals AC, that is common, and AB is equals CD, opposite sides of parallelogram, and then AD is equals, okay, AD is equals BC. Then it is not coming there. AD is equals BC now. BAC you have to write, not BAC. CAB. They check this. AC is equals AC, it is coming. AB, CD is equals AB. That is what I am checking. CD is equals AB. Yes, it is coming. AD is equals BC. Of course, it is coming. So that is it by what congruency? Triple S congruency. We have these angles DCA, that is equals angle BCA. So therefore AC bisects angle C. Got it? Any doubts in this? Okay. Or else we can go by that ASA also. Now we need to prove that ABCD is a rhombus. Shall I erase this one? No, because already opposite sides are equal in the parallelogram. We don't need to prove all sides are equal. It is enough to prove that only adjacent sides are equal. Okay. So the second one, how we are going to prove means this angle, right? To prove ABCD is rhombus. So this angle CAB, that is equals angle CAD, because it bisects. In the question itself it is given. Okay. Likewise this angle CAB that is equals what? CAB equals what? This half, shall we say? Oh, not that one. That half also we have to write. What is that? Angle DCA equals angle BCA, proven above. Now we can say this angle CAB equals what? By alternate interior angles, remember? CAB equals angle DCA. Okay, they are alternate interior angles. So that implies angle CAB equals angle BCA. Can you get what idea? What I have done? This angle is equals this angle. So that makes what? Hey Babu, these two, half of A is equals to this half of C. Correct? Instead of this half, we can say this half. That is the idea. When I say A, B, C, D and all, you may get confused. Yeah, or else you may number it 1, 2, 3, 4. Shall you number it? Hey, easy man. When you number it, it is much easier than 1, 2, 3, 4 like I am numbering. So we have, let me rewrite this. Angle 1 is equals angle 2. Okay, because it is given. And angle 3 is equals angle 4. That is also given. But we have angle 1 is equals angle 3 because they are alternate interior angles. So that gives us this angle 1 is equals angle 4. Correct? Because 1 is equals 3, 3 is equals 4. This would be much easier than this, right? Easy or tough? So we may say not but, that implies. Then we have this triangle ABC is isosceles. Don't write this rhombus. Okay. So isosceles now what we can say? AB is equals BC. But we have BC is equals CD and that other one AB is equals CD. So that gives us all the four sides are equal. So AB equals BC is equals CD, that is equals DA. I think I missed one side. BC is equals CD, not CD, AD. Okay. Any doubts on this? These are all opposite sides of parallelogram. So all the sides are equal in a quadrilateral. Then what we can say? This ABCD is a rhombus. Got it? Any doubts on this? Any doubts on this? Okay. So erase, that's it. Okay, now look at the fourth question. Can anyone say how to prove the fourth question? This side shall erase. Simple man, same like what we have done before. In the previous question, parallelogram they gave. Now in this question they gave ABCD is a rectangle. It bisects A as well as C. This part we have to do again, but with a rectangle. That is it. Okay. Proof is literally same. Instead of this, have you written this? Now see me how I am changing this. So ABCD is a question number what? 3 or 4? 4. ABCD is a rectangle, right? In that diagonals are the, not diagonal, only one diagonal they talk about. Same thing. 1, 2, 3, 4. Instead of parallelogram, what I drawn? Rectangle. This question draws parallelogram. Same proof. 1 is equal to 2. A and C are bisected by the diagonal AC. Is it or not? 1 is equals 2. Correct? 3 is equals 4. Correct? They bisected. And then this 1 is equals 3 because they are alternate interior angles. That makes this 1 is equals 4. The proof is that to prove that ABCD is a square. So then this triangle ABC is isosceles. We have AB is equals BC. But already we have what? They are opposite sides of a rectangle. Got it? So we got all the sides equal in the rectangle. What does it means? It is a square. What are the things I just changed? Diagram, I changed the parallelogram into rectangle. Here, instead of rhombus, I am proving it is square. Everything else is same. Okay. And diagonal BD bisects B as well as D. How we can prove this? Diagonal BD bisects B as well as D. See, we have all the sides are equal, right? By triplus congruency. It is not second subdivision, first subdivision. So, the second subdivision, diagonal BD bisects angle B and angle B. How we can prove this? Simple. Congruency between these two triangles. Why I erased this side? That is also same, right? No, it is not same because we proved angle C is bisected. Here B and D for that here. Okay. So this time also same triangles. In triangle ABC and triangle BD na vatra ABC and triangle AB is equal CD, right? CDA. CDA na AC, here also AC, correct? BC, CD. Okay. BC is not equal to CD. Triangle ABC. Yeah. Why took AC? For this diagonal, triangle ABD and triangle AB is equal to CD, yeah? CDB. That's all. Or else CBD we can write. So we have AB is equal CD and then AD is equals BC. Yes, correct, it comes. So these two triangles we need to prove it is congruent. What are all the things are common? So common are equal. We have, first we will highlight this triangles. This one and the other one is this one, correct? Only you may say corresponding angles are equal. Now obviously this side DB is common, DB or BD. So BD is equals BD, common, and anything else common or equal? Opposite sides equal, right? We have AD is equals BC, AD is equals BC, correct? And then AD is equals BC and then AB is equals CD. Those are opposite sides of a rectangle actually, or else square we may take. Now by what congruency? By triplus congruency, this triangle ABD is congruent to triangle CDB. So that gives us this part of B and C. Sorry, B and D are equal. Okay. Let them in, man. Got it? Any ideas? Any doubts? So by CPCT, yes sir. No one. Oh, okay. Okay, let's see. And then where was I? By CPCT we may see this angle B and D is bisected by, not bisected by CPCT, this BD bisects angle B as well as B. That's all. Any doubts in this? Any doubts in this one? Say yes or no? No. Okay, good. Shall I erase everything? This one? Okay. Then the question number 5. Parallelogram ABCD so it is A, B, C and D. The diagonal is BD. Also P and Q are points on the diagonal such that DP is equals DQ. Okay. So this is P, this is Q. So DP is equals DQ. That is given in the question itself. And the first thing we need to prove, triangle APD is congruent to triangle CQB. As usual, what is given we need to focus. It's a parallelogram. All the properties of parallelogram that may applicable. Now highlight these triangles APD and CQB. Here it is. Okay. Now what are all the common things between these two triangles? We have BQ is equals DP. That is given in the question itself. What else are equal? Can you see the diagram and say? Come on. Not even answering. Come on, say something. Say apple. Will you speak? No, we can't say angle B is equals angle D. Full angle only equal, but this triangle, this highlighted triangle, see, BD is common now. No, full side only it is common. That is why I highlighted these two triangles. See, BC is equals AD. Shall we say? AP? No, it is not given. That is the second subdivision we need to prove. The AD is equals BC, shall we say? Opposite sides of AD is equals BC. Okay. CB, both are same. Whatever. And then anything else is common means, since it is a parallelogram, this transversal BD, shall we say these two angles are equal? Don't fight with me, sir. I already said B sir, D sir means. B means full angle B. This is not even half. The exact name we should write. So that angle is what? ADP. Angle ADP equals angle ADP. I wrote then CBQ. Correct? CBQ. They are alternate interior angles for transversal BD. Okay. So by what congruency shall we say? The sides containing the angle are equal. Then it is what congruency? Come on, answer. What congruency, man? SAS congruency. Okay. This triangle APD is congruent to triangle CQB. Then second subdivision. Anybody has any ideas how to prove that? That is all by CPCT. So the second subdivision by CPCT from 1 AP is what, RAM? AP is equals CQ, correct? Yes, good. Now third subdivision. Two triangles given, AQB CPD. To prove triangle AQB is congruent to triangle CQB. AQB CPD, sorry. Okay. Here I about to write to prove. Instead of that I wrote like this. We may change this as in triangle. This and that, because initially we should not say unless it is a to prove statement. So first highlight the triangle. What triangle we are talking about? AQB means this triangle and CPD means this triangle. Come on, list out what are all the same things. I will not say anything. Come on. AB is equal CD because that is opposite sides of parallelogram. And then what do you mean is this angle and this angle is equal. Now tell me angle AQB or ABQ? ABQ is equals angle ABQ na CDP. They are alternate interior angles. Anything else? No right angle, sir. Sir, see, sir, this one, sir. BQ is equals PD. Correct? That is given in the question itself. Remember? Now what congruency? By SAS congruency. This triangle AQB is congruent to triangle CPD. Got it? Now fourth subdivision, very tough one. AQ is equal CP. How it is? That's all. Yeah, I said it is tough one. You answered simply by CPCT from 3. We have AQ is equals CP. That's all. And then fourth one, APCQ is a parallelogram. Shall I erase this side? This side. Okay. See, from what and what, man? That is second and fourth, right? Second and fourth. No, sir. Second and fourth, what we can say is AP is equal CQ, AQ is equal CP. Technically, opposite sides are equal in a quadrilateral. Okay. So, in quadrilateral, what is the term? APCD, yeah. APCQ, opposite sides are equal. Remember the property? In a quadrilateral, opposite sides are equal means, then how do we call the quadrilateral? Therefore, a rectangular opposite sides equal means property, 7 property, parallelogram. Okay. Yes, sir. Fourth only, man. This one is fifth one. My bad. So, let us this. Okay, man. Next question and all, I will not say anything. You are going to answer. I will draw the diagram. In the meantime, you just think. Hey, you said yes. You can write the proof, man. It's easy. Nothing else is there. Everything is here. The two proof statement alone missing. Here also. Congruency name missing. That is SAS congruency. That's all. Come on, finish writing fast. So, there is. Okay. Look at the diagram. Our sixth question. ABCD is a parallelogram again. BD is the diagonal. AP. This is CQ. And that is it. AB is a parallelogram. APCQ are perpendicular. That is what given. Show that APB is congruent to CQB. APB and CQB. Sorry, CQD. First, we will highlight the triangles. APB na and so angle 90 degree. What angle 90 degree? Angle APB equals angle CQD. Each 90 degree. Anything else we can say? AB is equals. Yes, good. So that is opposite sides of parallelogram. And then, shall we say AP is equal CQ? No, we can't say. What else? No. What about these two angles? What you can say about these two angles, man? AB is parallel to CD. BD is transversal. What you can say? This angle ABP is equals angle CDQ. They are alternate interior angles. Two angle on one side must be ASA. Is that ASA or AAS? ASA or AAS? 90 degrees coming, RHS should come, right? AAS, because this side is not common for these two angles. Okay. So by AAS congruency, we have this triangle APB is congruent to triangle CQD. Okay. And AP is equal to CQ. Very tough one. That is all. By CPCT, AP is equals CQ. Next, the 7th question. So I write the same. Last question of this exercise. ABCD is a trapezium in which AB is parallel to CD. AB, CD, and AD is equals BC. AD is equals BC. That is it given in the question. Okay. In the exam, they will not give extend this, that, and all, hint and all. We should be aware of these things. We need to show that angle A is equals angle B. So, in that, we have to extend this B to E. Exam, we have to put diagram. The diagram will not be given. If diagram given also, whether they will mention this extension or not. But we have to write in the part, construction part as well. Okay. And extend CE. Sorry, connect CE. That CE is parallel to AD. Also, we have AB is parallel to CD, right? So, opposite sides are parallel. What we can say? Parallelogram. What is parallelogram? ADCE is a parallelogram. Okay. Now we need to prove angle A is equals angle B. These two we have to connect. Shall we connect these two directly? We will name the angles. I am naming this is 1, 2, 3 and 4, just for convenience purpose. So, A is equal to B, that means 1 is equals to, we need to prove. So, since ADCE is a parallelogram, we say AD is equal to EC, correct? Correct. Opposite sides of parallelogram. But it is given that AD is equals BC. Then we have this EC is equals BC. That means this triangle BEC is isosceles. Is it or not? Can you understand? When BEC becomes isosceles, what we can say? Angle 3 is equals angle 4. Shall we say? Say yes or no, man. Answer me, man. So, angle 3 is equals angle 4. So, the reason angles opposite to equal sides. Okay. But we have this angle 1 plus angle 4 is 180 degree. They are adjacent angles of a parallelogram. Okay. See, angle 1 plus angle 4, that is equal to 180 degree. They are adjacent angles of parallelogram. So instead of 4, what we can substitute? Angle 3 is equals 180 degree. Okay. Then we need to connect this 1 and 2. But what we done is 1 and 3 is connected. So somewhat 2 also we should get that into the picture. How we can get that inside? But this angle 2 plus angle 3 is 180 degree. Why? They are linear pair. Okay. So then angle 3 is what? 180 degree minus angle 2. Substitute over there. Then angle 1 plus 180 degree minus angle 2 equals 180 degree. 180 out. Angle 1 is equals angle 2. That's all. So angle 1 is equals to angle 2 means what? Therefore, angle A is equals angle B. Any doubts in this? Once again I will explain. See, they told us to prove these 1 and 2 are equal. We can't relate 1 and 2 directly. Okay. But we have relation between 1 and 4 and 3 and 4. So from that 1 and 3 can be related. So 3 and 4 are equal, that we know. 1 and 4 when you add it, it is 180 degree. Instead of 4, I substituted 3. Okay. And then this 3 is related with the 2. How it is related? This angle 2 plus 3 is 180 degree. Then substitute in terms of 3, that is 180 degree minus 2. That is again substituted in this relation, means we get angle 1 is equals angle 2, which is angle A is equals angle B. Okay. Now next one. Angle C is equals angle D. How we can prove that? Shall I erase this? Come on, write fast. Shall I erase this side? Why this side? There itself we can prove. So we have angle A plus D is 180 degree, is it? Also we have angle B plus C. In a trapezium I am speaking. When I say angle B, that mention this 2 alone. Because trapezium only matters, that is given in the question. So angle B plus angle C is equals 180 degree. So name this is 1 and 2. Subtract 1 and 2. 1 and 2 sorry, 2 from 1. 1 from 2. 2 subtracted from, sorry, 1 subtracted from 2. Then what do we have here is angle C, sorry, angle B plus angle C minus angle A minus angle D equals 0. Since B and A are equal, we can cancel this each other. Reason, angle A is equals angle B. Okay. So then we have this side shall erase. Then we have angle C minus angle D equals 0. That means angle C is equals angle D. Hence proved. Then third subdivision, we need to prove that diagonal AC, not diagonal AC. ABC is congruent to BAD. ABC is congruent to, yes man. Ask me. You're not audible. Yes man. Tell me again. Tell me again, come on. What is the doubt? Yes sir, tell me sir. Oh, you're telling the answer. Okay, okay. ABC and BAD. And triangle BAD. We need to say those are congruent. So ABC, no, there is no triangle. You should draw this diagonal. And BAD. So obviously we have AB is common. So here ABC means this one, right? ABC na angle B, that is equals angle A. Also in the question itself they given that AD, yeah? No. ABC na, which one we have to write? BC is equals AD. Okay. So it is given. It is proven above. What congruency? Yes sir. Man, two sides, one angle. The sides containing the angle are equal. By SAS congruency, we may say this triangle ABC is congruent to triangle BAD. Then fourth subdivision, very tough subdivision. How to prove the fourth one? Anybody? Do the honor, man. Very tough one. Finish it. Diagonal AC is equals diagonal BD. By CPCT, AC is equals BD. That's all. Any doubts in this? I thought that we can finish this exercise as fast as we can so that we can move on to the next exercise. It turns out that for this exercise itself, the session is over. What's your idea about the midpoint theorem? Do you guys have any doubt? What do you think? Shall we continue midpoint theorem or shall we skip? Continue means we'll continue, man, not a problem. For what I am asking means we have to start our IIT syllabus and all. That is why I am asking. No. Take a deep breath, think yourself and say. If you are okay with that, we'll continue with the midpoint theorem, we'll finish it. Next one session is enough. You can finish it. After that, we'll move on to the next chapter. Then as soon as possible, we can start our IIT questions. Okay.